Hi, my name is Rob Slay. Today I'm going to demonstrate how to use FlexOTO to maximize utilization of instruments for optical transceiver test. This video will focus on how FlexOTO makes it easy to scale the number of devices being tested by a single DCA instrument. I'll demonstrate key features of FlexOTO that enable you to quickly and effectively assess the hardware utilization metrics of your test system.
Here are the test scenarios we'll use to test 800 gig transceivers using one N1092B oscilloscope. Setup 1 characterizes a single 800 gig transceiver using an optical switch and a 2-channel DCAM. Setup 2 uses the same switch and N1092B oscilloscope, but it characterizes 3 800 gig transceivers. In manufacturing applications, a transceiver is often tested at several temperatures. Typical test flows consist of an initial tuning process, followed by transmitter tests, receiver tests, and perhaps other tests such as wavelength and side mode suppression ratio or SMSR tests. For this demo video, we're going to simplify things by simulating a 1-minute temperature ramp, and we're only going to perform the transmitter tests. This will yield a best case hardware utilization, but know that FlexOTO can also optimize hardware utilization of other instruments in your test system. What you'll see in this demo is how easy it is to use FlexOTO to set up and control your test system. You'll see how fast FlexOTO is able to perform measurements and how it automatically sequences multiple devices to optimize hardware utilization. Let's start by setting up FlexOTO via the GUI. I'll start by setting up the optical switch that's been automatically detected by FlexOTO. Then we're going to configure the device that we'll be testing. It can be a single lane device or a 4-lane device, where in this case, we'll start out by testing a single 800 gig device comprised of 8 lanes, each lane running at 100 gigabits per second. Now we'll configure the DCAM that FlexOTO has automatically detected. It's an N1092B 2-channel optical reference receiver with integrated clock recovery. You can see all the activity at each of the 4 temperatures, 25, 0, 70, and back to 25C. But for this setup, the DCAM hardware was only busy 37% of the time. So let's see how easy it is to test more devices on this test station. Let's stop FlexOTO and add more devices to our test setup. It's as easy as simply dragging 2 more 800 gig devices and attaching them to our switch. Of course, they have to be physically present. We'll speed up the test to save time in the video, but you can see the acquisition and analysis time for each of the 3 devices. The fixture view very clearly shows the entire test program for all 3 devices being characterized at the 4 temperatures. Each DUT is waiting for a 1-minute ramp time before being tested again, and you can see the DCAM hardware is hard at work most of the time, so the utilization is very high. If we switch back to the engine's view, we can see that the hardware utilization is actually 95%, which is very good, and the entire test program took just 5 minutes and 49 seconds to test 3 800 gig devices at 4 temperature settings using a single N1092B 2-channel oscilloscope. The test results can be quickly saved via GUI or programmatically. It will save all the results and the underlying waveforms along with NEI diagrams that you ask FlexOTO to capture. This demo shows how easy it is to set up FlexOTO, how fast it can perform conformant transmitter measurements using hardware you already own, and how easy it is to check and optimize hardware utilization of your test system.
So that was a quick overview of how to use FlexOTO to assess the hardware utilization of your test system, and thanks for watching.